And welcome back. In previous videos, video number 5 and video number 6, we solved for condition where the initial velocity is the same as the final velocity, or it means that there's no change in the object's state of motion. So it means if it's not moving, at the end when you apply the force, or when it was moving, it did not change the speed, it did not change the direction, or it means that the acceleration is 0. So there's no change in acceleration, or there's no change in velocity, so there's no acceleration. So acceleration is 0. This time we have a condition where the initial velocity is v, and then the final velocity after you apply the force is at 2v, or twice the initial velocity. So there is an increase in velocity. And also, as you observe our illustration, the force is applied not along the horizontal axis, even though according to the problem, the block is being dragged along the horizontal surface. If you're dragging it along the horizontal surface at an angle, and the angle is measured along the horizontal axis, okay, so it means it's moving. Of course, another information that we should know is that it does have mass. Okay, any object, okay, as we say it, a matter is anything that has mass and occupies space. Now we all know that there is motion. So if there's motion, there is coefficient of friction, and coefficient of friction means that this is the ideal condition, not ideal condition, but actual condition where friction do exist. So we have friction along the surface between the block, the motion of the block. So since it's moving, then we will be using mu k. Okay, mu k, or the coefficient of kinetic friction. Our first information here is we have to solve for the acceleration. Okay, acceleration along the x-axis. So we are going to be solving the acceleration along the x-axis, not along the y-axis, because it states over here the block is dragged along the horizontal surface. So it means right away, so we are going to analyze the velocities or the acceleration. The acceleration along the y-axis is still going to be 0 because the motion is only along the horizontal surface. Now our horizontal acceleration, a sub x, is going to be a, is it negative or positive? Okay. Since it is increasing in terms of speed, okay, it is increasing in terms of its rate from v, now it's twice the velocity. Okay, so it's twice the velocity. So we will be able to solve for positive acceleration along the x-axis. Also, how much is that force that you apply? Okay, how much force can you apply in order to maintain, or in order to create that acceleration? So we have to solve for the acceleration, and then afterwards, what is the amount of force needed in order to come up with this acceleration, positive a, along the x-axis? Now, if we want to challenge ourselves, maybe let's add up the third question. Why don't we try to solve for the time? How long will it take for this object with the amount of force applied to accelerate from v to 2v? Okay, so from v to 2v, what is the time? Okay, so time. Now, let us start with the first step, of course, and that is to draw our free body diagram. Okay, so let us begin. Free body diagram. Free body diagram. Free body diagram. First, of course, first step, or the usual thing that we do, is to draw our imaginary axis. That's your y, and this is our x, and this is the dot where all of the forces would meet. Okay. Now, as we mentioned earlier, x is measured along the x-axis. Okay, x, it means that if you have the angle is in between your x-axis and the applied force. It means that it's measured along the x-axis. Now, if this angle is written on the other side, then it is measured along the y-axis. But since this problem is measured along the x-axis, so we will proceed by analyzing it along the x-axis. Okay, first step, of course, let's draw the dot, transfer it here. We have our first force, and that is the force of gravity or weight, Fg. Another force that is acting between the surface, and that is your normal force. Okay, normal force, it's not the same length as your force of gravity because there is another force that is acting on the object along your y-axis, and that is your force, applied force F. Okay, so if you add those two forces, it should balance out because according to our acceleration along y-axis is 0, so there's no change in the state of motion. And also, since it's moving, definitely the force of friction is going to be considered as kinetic friction. So force, kinetic, friction. Okay. So kinetic friction. Now, this is your solution. This is your free body diagram for the person grading your work. Now, this is the solution where the consumption is just for you. This is for you to analyze and come up with an answer. Again, let us draw the dot. And this dot will have the different forces. The first one is Fg. Okay. Then we all know that force of gravity or weight is simply mass multiplied by g. If it's weight, then mass multiplied by the gravitational field strength, gravitational force in terms of inertial mass, then mass multiplied by the acceleration due to gravity. Normal force, which is Fn. And then we have our, of course, our force of friction or force of kinetic friction. So that will give us mu k multiplied by Fn. So normal force. Okay, normal force. And then we have the other force acting here, which is your F. Okay. Again, let us draw our forces, our components. Okay, components of force F, because it is applied at an angle, okay, not along the axis. So why don't we use the dotted lines of red for our Y, and then blue for our x-axis. F of x. Okay. Again, let me just reiterate that it is measured along the x-axis. So if the angle is inside, in between the x and the force applied, then we have to use sine for y, and cosine is your x. So if I am going to write it here, so f sub x is simply equivalent to f multiplied by cosine of that angle theta. Cosine of that angle theta, and f sub y is equivalent to f multiplied by sine theta, since it is measured along your x-axis. Now, further, let us draw our final free body diagram for us to put all the forces that we want to see. And now this one is your Fg, which is m times g, the normal force. And then we have our force of kinetic friction, which is your coefficient of kinetic friction multiplied by the normal force. And then we have our components. So now we have our x of x, which is f of cosine theta. Then we have f of y, which is our f of sine theta. Okay, f of sine theta. Now that we have this, okay, so now let's proceed by analyzing the forces and applying the second law of motion. So that will be our summation of forces. Summation of forces along our y-axis is equivalent to mass multiplied by the acceleration along the y-axis. So positive going to the, going upward, going down is negative. So we have forces going up, which is the normal force, plus a force going up, which is our y component of the applied force, F sub y, minus force of gravity Fg, which is equivalent to mass, and the acceleration, which is 0. Normal force Fn plus F sine theta minus mass times g, since that is your force of gravity. So all I have to do, keep Fn by itself in one side of the equation. So that is Fn, bringing our mass times g, or force of gravity or weight, to the other side of the equation, changing it from negative to positive, mg minus F sine theta. So that will be for our y-axis. Now, this time, let us work for our x-axis. Okay, so x-axis. So summation of forces along our x-axis is mass multiplied by the acceleration along x-axis. This time, the acceleration along x-axis is not 0. It's positive because it's increasing in terms of speed, okay, in terms of its rate. So why don't we just plug in those values? Positive to the right, so that is Fx minus force of kinetic friction is equivalent to m multiplied by the acceleration. Now, f of x, which is cosine theta, and then we have minus mu of kinetic friction multiplied by the normal force is equivalent to mass times the acceleration. Okay. Mass times the acceleration. So for us to solve for the kinetic static friction or kinetic friction, of course, that is something that's already provided to us. So we are not solving for the kinetic friction, but instead we are solving for the acceleration due to the applied force. So all we have to do is divide both sides by the acceleration or by mass to get our acceleration. So we can say, by dividing both sides by acceleration by m, so this will give us a, okay, and that is f cosine theta minus mu k times normal force, which is Fn over m. But we all know that normal force is right here. So what I'm going to do is plug in the value of normal force right here, okay, We might need some extra paper later for the next part of a question, but that's fine as long as we come up with a much, I would say, organized solution so you could all understand what we're doing. So now A for the acceleration. So F cosine theta minus mu of K, or the kinetic coefficient of kinetic friction, multiplied by Fn. That is mg minus F sine theta over m. So now let us distribute mu k to the value of Fn. So now we have A which is F cosine theta minus mu k mg, and then negative times negative, that will give us positive mu sub k, or the coefficient of kinetic friction, multiplied by F sine theta m. So what I'm going to do, I will combine the coefficient of the variables that are the same. So I have F and F over here. Okay. So what I'm going to do is combine those two coefficients, the coefficient of those two of the variable F. So I can say F, and that is cosine theta, plus the coefficient of static friction multiplied by sine theta, and then subtracted by mu k, or the coefficient of static friction or kinetic friction, divided by multiplied by mass times g, which is our force of gravity or weight, divided by m. So this will be our answer for letter A. So here's our answer for letter A. Okay, answer for letter A. Get familiarized with this video, with the solution, with the answer. It is very, you will benefit from it, especially when it's a multiple choice question, and all you have to do is select which one do you think is correct. So now we have the solution to that kind of question. So this is for letter A. What is your acceleration? Now, to give us enough space, why don't we get another sheet of paper? Okay, so what I'm going to do is use another sheet of paper. Okay, so use another sheet of paper. So what I'm going to do is move my video somewhere here. Okay, I will be moving my video so you could see the solutions at different angles. Okay, now, so for letter B, how do we solve for F? Okay, F. So what I'm going to do is to use that section where the motion is. So for example, we're moving along the horizontal axis. You can use this. However, it's more appropriate if we use our equation that is along your x-axis, because the motion is along the x-axis. So let us write it down. So that will give us, so right over here. So I will start from this section right here. So how do you solve for F? So I'm going to change my color pen. Let me just use the green one so it's easier for us to identify. So letter B. Okay. Solve for F. Okay, so solve for F using the summation of forces along our x-axis, mass times the acceleration, okay, which is right here. This one and this two are going to be there. All right, so let us write it down. So F, let me just zoom it in. So let us zoom in so you can see it. So what I'm going to do so you could see it. So which is this one right here to this. So F cosine theta minus mu k f of n equals mass times the acceleration. Okay, now let's plug in the value of Fn again. So let's have it here. F cosine theta minus mu, or the coefficient of kinetic friction, multiplied by mg minus F sine theta equals m multiplied by the acceleration. Again, distribute. So that is F cosine theta minus mu k mg. Negative times negative, that will give us positive mu k F sine theta equals mass times acceleration. Okay. So what I'm going to do, since we have already plugged in most of the values from the previous sheet, okay, I will just use this so no one get confused, and then you can see my handwriting. Okay, so it's easier to see. So now let us combine the coefficient of the same variables. Okay, combine like terms. So F and F can be combined together. So if I can say F, let's combine the coefficients, which is cosine theta, okay, plus mu k sine theta minus mu k m times g is equivalent to mass times the acceleration. Okay, so now I want my F to be on one side of the equation only. So let's transfer this to the other side of the equation. So now I have F cosine theta plus mu sub k sine theta, and that is m multiplied by the acceleration due to the applied force F plus mu sub k, or the kinetic coefficient of kinetic friction, multiplied by mass and the acceleration due to gravity. Oh, there's common. Cosine theta plus mu k sine theta. Okay. So common in both is your m, so we can just say a plus mu k times g. And then of course we're not finished yet, because we want to express our answer in terms of f, or f in terms of given information. So let's divide both sides by this coefficient of f. So we can say that f is simply equivalent to m multiplied by a plus mu, or kinetic coefficient of kinetic friction, multiplied by g, divided by cosine theta plus mu k sine theta. So this will be our answer for letter B. So what does it mean over here? If I increase the mass, what happened with the force? Okay. If you increase the mass, the force needs to increase. If you increase the angle, okay, what will be the effect? Okay. If you increase the angle, for example, if we have 90 degrees cosine, then this one will be 0, this one is 1, so you divide it by the coefficient of kinetic friction. The whole numerator is divided by this. So that is the effect of force in terms of the acceleration. So, okay. So analyzing it, what happens if you increase the acceleration, increase the mass? The force need to be increased also. Okay, so if the block becomes bigger, then you need to increase the amount of force in order to attain this kind of acceleration. So this is for letter B. Now letter C, it's just for fun. Letter C, we just added letter C just for fun. Okay, just for fun. Sometimes problem solving is for fun. As I'm moving my picture out of my face as we're watching this video. Okay, so for letter C, how do you solve for T? Okay, so you have different equations that involves initial velocity, final velocity, and then time, and then acceleration. So in our case, we don't know distance. Distance is not given, so we will not use the second equation and the third equation for our kinematics. Okay, so again, let me just repeat what I'm saying. We will not use the second or the third kinematic equation, but instead we will rely on the first kinematic equation. And what is the first kinematic equation? The initial velocity or the final velocity is simply equivalent to the initial velocity plus A times T. All right. So how do we solve for T? Okay. So we can say that T is simply equivalent to our initial velocity, so final velocity minus the initial velocity over the acceleration. Okay, so that's the acceleration. How long will it take for it to travel? How long for it to take so that it will travel at this acceleration? Okay, provided you know the force. Now we know that the initial velocity is v. This one, final velocity is 2v minus v over acceleration. So we can say the time is simply equivalent to v over a. Okay, but we all know that acceleration is also equivalent to f and all this whole component right here that we have to add. Okay, so if we want to add and we have to put it in our equation, then let's see what happens. Okay, so all we have to do is put t. Let me just write it here so we could all see. So you divide, instead of using a, let's put all of these values right here, which is f multiplied by cosine theta plus mu, or the coefficient of kinetic friction, sine theta, minus the coefficient of kinetic friction multiplied by mass and g over m, and this one is the velocity. So now we can just say that time is mass multiplied by the velocity divided by the force cosine theta plus coefficient of kinetic friction sine theta minus mu k times m and g. So what happens? Okay, so let's analyze this. Okay, so let us analyze how essential is this one. Does it make sense? Does the equation make sense over here? We're answering letter C. So what does it mean? Since the force is in the denominator, it means that the greater the force, the lesser the time it will take. Of course, you apply more force. You apply more force, okay? You apply more force, and what happens? You lessen the amount of time to accelerate. Okay? Now, if you increase the velocity, let's say this velocity turns out to be 3m instead 3v instead of just v. Now you have to take more time if you don't change the force. Okay, so the greater the velocity means the greater time needed in order to reach that certain velocity. How about the mass? Since mass is both in numerator and denominator, what is the effect? Okay, what is the effect? It will subtract force from the applied force because mass is part of this equation right here in the bottom, part of the numerator, but you need to subtract this from the force itself. Okay, you subtract it from the force itself. Then you increase the mass on the top, so it requires longer time for you to travel if you increase the mass. So it explains this information. Again, the greater the force you apply, the lesser time it requires to accelerate at a certain speed. You increase the speed, the target speed, what happens is that you will require more time in order to reach that target speed. Increasing the mass means you have to increase the amount of force. If not, time is affected as well. Okay, so thank you. I know it's a lot for this video. It's a lot about this video. Hope you can catch all of it in your screen. Let me just move it a bit. It is a lot, however, it is very important that we know how it's derived and how does it affect our ability to explain what's going on in terms of the scenario. Okay, so in our next video will be a different setup, but it will be related to this video again.